Hello, in this lecture we will find the radius of a circle enclosed in a triangle. In the drawing you can see triangle ABC. Side AB of the triangle equals to 4 units, side BC equals to 3 units, and side AC of the triangle ABC equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared. And in the triangle we have a circle, and we want to find the radius of this circle. First of all, let's define the center of this circle as O. Point O is the center of this circle. And actually, the touching point between side AB of the triangle and the circle will be defined as N. Again, the touching point between side AB of the triangle and the circle is defined as point N. And we can also say that side AB of the triangle is tangent to the circle at point N, and in the same way we will define the touching point between side BC of the triangle and the circle as M. Point M is defined as the touching point between side BC of the triangle and the circle. And we can also say that side BC of the triangle is tangent to the circle at point M. Okay? We can also say that M is the point of contact between the triangle and the circle. Okay, and in the same way, the touching point between side AC of the triangle and the circle will be defined as P. Again, point P is defined as the touching point between side AC of the triangle and the circle. Okay, or we can also say that side AC of the triangle is tangent to the circle at point P. Okay. In the next step, we will connect together by a straight line points O and N. Actually, the line segment NO is the radius of this circle. I will mark it as R, small r, because it starts, line segment NO starts from the center of the circle and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of this circle. And in the same way, we will connect together by a straight line points M and O. And from the same reason, line segment MO is the radius of this circle, and I will mark it as R, because it starts from the center of the circle and ends at point M, that is a point on the circle itself. For that reason, line segment MO is the radius of this circle. Actually, the definition of a radius of any circle is any line segment that is in the circle itself and starts from the center of the circle and ends at any point on the circle itself is defined as the radius of a circle, and actually those two line segments NO and MO satisfy the definition of a radius of a circle. For that reason they are radiuses of this circle. And we will also connect together points O and P by a straight line. Actually, line segment OP is the radius of this circle because of the fact that it starts from the center of the circle, that is to say point O, and ends at point P, that is a point on the circle itself. For that reason, line segment OP is the radius of this circle. Actually, those three line segments NO, OP, and OM satisfy the definition of a radius of a circle. For that reason, they are the radiuses of this circle. Okay? And I repeat again, side AB of the triangle is tangent to the circle at point N. Side AB of the triangle is tangent to the circle at point N. Side BC of the triangle is tangent to the circle at point M, and side AC of the triangle is tangent to the circle at point P. Okay? Actually, we have a rule. I will call it rule number 1. Rule number 1 states that in any circle a radius and the tangent to that radius are perpendicular to each other. I will read again rule number 1. Rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius is perpendicular to its tangent. Okay, so actually we can implement rule number 1 in our circle because we have 3 radiuses and we have 3 tangents to these 3 radiuses, and according to rule number 1, the radiuses are perpendicular to its tangents. So for example, line segment NO is the radius of this circle, and the side AB of the triangle is tangent to this radius. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONA equals to 90 degrees. and also angle ONB equals to 90 degrees. Okay, and if we look at line segment OM, that is the radius of this circle, we have the radius, this radius, and we have the tangent BC to this radius. And according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees, because of the fact that the radius is perpendicular to each tangent, tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, and for the same reason, line segment OP, that is the radius of this circle, is perpendicular to its tangent AC. And according to rule number 1, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees, because the radius is perpendicular to its tangent. This is the radius and this is the tangent to this radius, and they are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay? And actually, the formula for the area of the triangle of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay, so the formula for the area of any triangle equals to the base of the triangle times the height to the base divided by 2. And you should remember that the height always creates 90 degrees, which is base. Okay? Instead of the area of the triangle, we can use the capital letter A, that is abbreviation for area. We can say that A equals to the base of the triangle times the height to the base all divided by 2. Okay? So the area of any triangle equals to the base of the triangle times the height to the base divided by 2, and I repeat again, the height of a triangle always creates 90 degrees with its base. Okay, we actually can implement this formula in order to find out the areas of the triangles that inside the big triangle. But first of all, we will connect together points B and O by a straight line. And we will connect together points O and C by a straight line. And we will also connect together points O and A by a straight line. In the next step, we will calculate the area of the green triangle. So according to the formula that I presented 2 minutes ago, the area of any triangle is the base of the triangle times the height to the base divided by 2. So the area of the green triangle, that is triangle OBC, equals to the base of the triangle. The base of the green triangle is given to us. It's equals to 3 units. The base times the height to the base. The height is the radius because the height creates 90 degrees with its radius, with its base. The base is BC and the height should create 90 degrees with its radius. So the height must create 90 degrees with its base. For that reason, the radius is the height of the green triangle, because the radius creates 90 degrees with the base. Angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. So it is 3 times the radius divided by 2. Again, the area of the green triangle equals to the base of the triangle, that equals to 3 units, times the height. The height of the green triangle equals to the radius, because the radius creates 90 degrees with the base of the triangle. For that reason, the radius is the height of the green triangle. So it is the base that is 3 times the height, that is R, divided by 2. 3 over 2 equals to 1.5, so I write it down. So actually, the area of the green triangle equals to 1.5 times the radius of the circle. Okay? It is the base of the triangle that is 3 units times the height, that is R, divided by 2. 3 over 2 divided times R is 1.5 times the radius. Okay? 3 over 2 times the radius equals to 1.5 times the radius. Okay, and in the same way, we will calculate the area of the yellow triangle. So the area of the yellow triangle, triangle AOC, will be equal to the base of the triangle the base is given to us, and it is 5 units times the height of the yellow triangle. The height should create 90 degrees with the base, so the radius creates 90 units with the base AC. So it is 5 units the base of the triangle times the height, and the height of the yellow triangle is the radius, because the radius creates 90 degrees with the base. So it is 5 times the radius divided by 2, or the area of the yellow triangle equals to the base, that is 5 units, times the height, that is the radius, divided by 2. 5 over 2 is 2.5, so I write it down. So in total, the area of the yellow triangle equals to 2.5 times the radius of the circle. Okay, and in the same way, we can calculate the area of triangle AOB, or actually we'll calculate the area of the orange triangle. So the area of the orange triangle equals to the base of the orange triangle, that is 4 units. It is given us in the question. The base times the height of the orange triangle. The height creates 90 degrees with the base, so the height of the orange triangle is the radius of the circle. So it is 4 times the radius divided by 2. The base is 4 units times the height, it is the radius, divided by 2. So the area of the orange triangle equals to the base, that is 4 units, times the height, that is the radius, divided by 2. 4 over 2 equals to 2, so I write it down. So the area of the orange triangle equals to 2 times the radius of the circle. So we can summarize and say that the area of the green triangle equals to 1.5 times the radius. The area of the yellow triangle equals to 2.5 times the radius. And the area of the orange triangle equals to 2 times the radius of the circle. Okay? But we also know that actually the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle, because the big triangle ABC contains those 3 triangles, those 3 small triangles. Okay, so we can write down the first equation that states that the area of the big triangle ABC equals to the sum of the areas of the green triangle. The area of the green triangle is 1.5 times the radius, plus the area of the yellow triangle. The area of the yellow triangle is 2.5 times the radius, plus the area of the orange triangle, that is actually equals to 2 times the radius. So in total we got the first formula that states that the area of the big triangle ABC equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So the sum of those three areas equals to the area of the big triangle ABC. So we can summarize this side of the equation. 1.5 times the radius plus 2.5 times the radius equal to 4 times the radius. And 4 times the radius plus 2 times the radius equals to 6 times the radius. So the sum of this side of the equation equals to 6 times the radius. So I write it down. So the area of triangle ABC, the big triangle ABC, equals to the sum of the areas of those three triangles, the green triangle plus the yellow triangle plus the orange triangle, and the sum of those the areas of those three triangles equals to 6 times the radius of the circle. According to our calculation, this side of the equation is summarized to 6 times the radius. So the area of triangle ABC equals to 6 times the radius of the circle. Okay? The area of triangle ABC equals to 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units squared. It is given us in the question. So we actually can substitute the area of triangle ABC by 6. Okay? So instead of the area of triangle ABC, I write down 6 because the area of triangle ABC equals to 6 units squared. 6 equals to 6 times the radius. This is the summary of this side of the equation, 6 times the radius. So we got that 6 equals to 6 times the radius. We can divide this equation by 6, and we will get that the radius of the circle equals to 1 unit. Okay? So the answer to the question is that the radius of this circle equals to 1 unit, or the radius of the circle that is enclosed inside the triangle equals to 1 unit. Now I will summarize the lecture. Actually, we wanted to find out the radius of the circle that enclosed in triangle ABC. We know that side AB of the triangle equals to 4 units, side BC of the triangle equals to 3 units, and side AC of the triangle equals to 5 units. And we want to find out the radius of the circle that enclosed inside this triangle. First of all, we defined the center of this circle as O. Point O is the center of this circle. And then, actually, the touching point between side AB and the circle is defined as N. And N also, we can say also that side AB is tangent to the circle at point N. Side BC of the triangle is tangent to the circle at point M. And side AC of the triangle is tangent to the circle at point P. In the next step, we connect it together by a straight line point O and N. Then we connected together points O and M by a straight line, and we connected also point O and P by a straight line. Actually, those three line segments, NO, MO, and PO, are the radiuses of this circle because of the fact that they are all starts from the center of the circle and ends at any point on the circle itself. For that reason, they are the radiuses of this circle. According to the definition of the radius of any circle is defined as any line segment that is inside the circle and starts from the center of the circle and ends at any point on the circle itself. Okay? Actually, those three line segments satisfy that definition of a radius of a circle. For that reason, those three line segments are the radiuses of this circle. Okay? And in the next step, we actually have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius that we call R and the tangent that is called T, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle is 90 degrees also. So in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay? So actually we can implement rule number 1 in our circle because we have here three radiuses and three tangents to those radiuses, and according to rule number 1, they are all perpendicular to their tangents. So actually, line segment NO, that is the radius of this circle, is perpendicular to its tangent AB. That is to say, angle ONA equals to 90 degrees and also angle ONB equals to 90 degrees. In the same way, we can say that line segment OM, that is the radius of this circle, is perpendicular to its tangent BC. That is to say, angle OMC equals to 90 degrees and also angle OMB equals to 90 degrees. Okay? And in the same way, we can say that line segment OP, that is the radius of this circle, is perpendicular to its tangent AC. That is to say, angle OPA equals to 90 degrees and also angle OPC equals to 90 degrees. Okay? And we also have the general equation for the area of any circle is actually equals to the base of that. We have the area, the general equation for the area of any triangle. The area of any triangle equals to the base of the triangle times the height to the base divided by 2. Or instead the area of the triangle, we can use the abbreviation A. A is the abbreviation for area. So the area of the triangle A equals to the base of the triangle times the height to the base divided by 2. And you should remember that the height of the triangle creates 90 degrees with its base. Or the height must create 90 degrees with its base. The height of the triangle must create 90 degrees with its base. Okay, so we actually can implement this formula of the area of a triangle in our circle in order to find out the area of the green triangle equals to the base of the triangle, that is 3 units, times the radius, times the height. The height creates 90 degrees with the base, for that reason, the radius is the height of the green triangle, because it creates 90 degrees with the base. Angle OMC equals to 90 degrees, and also angle OMB equals to 90 degrees. For that reason, the radius is the height of the green triangle, so the base, that is 3 units, times the height, that is the radius, divided by 2, is the area of the green triangle. So the area of the green triangle equals to 1.5 times the radius, because 3 over 2 equals to 1.5. So in total it is 1.5 times the radius. That is the area of the green triangle. And the area of the yellow triangle equals to the base of the triangle, that is 5 units. It is given us in the question. The base times the height of the yellow triangle. The height creates 90 degrees with the base. So the height must be the radius, because the radius of the circle creates 90 degrees with the base. Angle OPC equals to 90 degrees, and also angle OPA equals to 90 degrees. For that reason, the radius of the circle is the height of the yellow triangle. So in total, the area of the yellow triangle equals to the base, that is 5 units, times the height, that is the radius, divided by 2. Of the area of the green triangle equals to 5 over 2 times the radius. 5 over 2 equals to 2.5, so in total the area of the yellow triangle equals to 2.5 times the radius. And we also calculated the area of the orange triangle. The area of the orange triangle equals to the base of the orange triangle, that is 4 units. It is given us in the question, times the height. The height is the radius of the circle, because it creates 90 units with the base. So in total the area of the orange triangle equals to the base, that is 4 units, times the height, that is the radius, divided by 2. 4 over 2 is 2. So in total the area of the orange triangle equals to 2 times the radius. So the area of the green triangle equals to 1.5 times the radius. The area of the yellow triangle equals to 2.5 times the radius, and the area of the orange triangle equals to 2 times the radius of the circle. And we can also say that the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. So we can create equation number 1 that states that the area of triangle ABC equals to the area of the sum of the areas of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So the sum of those 3 triangles equals to the area of the big triangle ABC, because of the fact that the big triangle ABC contains those 3 triangles, the yellow triangle, the green triangle, and the orange triangle, and the sum of those 3, the areas of those 3 triangles equals to the area of the big triangle ABC. Okay, so question number 1 again states that the area of triangle ABC equals to the sum of the areas of the 3 triangles, the green triangle, the yellow triangle, and the orange triangle. So the sum of this side of the equation equals to 6 times the radius. So we got that the area of triangle ABC equals to 6 times the radius of the circle. But we have already known that the area of triangle ABC equals to 6 units squared. So we can substitute the area of triangle ABC by 6, because the area of triangle ABC equals to 6 units squared. So we got that 6, we substituted the area of triangle ABC by 6, and we got that 6 equals to 6 times the radius. We divided equation number 1 by 6, and we got that the radius of the circle equals to 1 unit, or the radius of this circle that's inscribed in triangle ABC equals to 1 unit. Okay, thank you very much.